Welcome back. The last thing that we have to talk about in relation to quadratic functions for now is models, which means word problems. Okay, so we're going to work with some context that quadratic functions come out of more frequently, actually. Okay, the first example is kind of just a little fun puzzle. Okay, so we're looking for two real numbers, call them x and y, and we know that the difference of them is 12. Okay, and you might need to, if you wanted to, you could try guessing and checking if you felt like integers, using integers, but they might not be whole integers or whole numbers, right? Positive or negative whole numbers. So to find them more precisely, we should set up an equation, find them, but it says there's a constraint here. It says find them so that their product is as small as possible. And so what we're looking for is a minimum. Okay, we know in our study of quadratic functions, we either have a maximum or minimum occurring at the vertex. Okay, so if we're looking for a minimum, we're hoping to find an instance where we have a quadratic function whose graph would be concave up, and then if that happens, we would have a minimum occurring. Let's get started. Okay, so I like just mathematizing everything that I can as quickly as possible. So the difference of two real numbers, okay, how do I write the difference? Difference is subtraction. So x minus y, and I don't know if it's x minus y or y minus x, it'll come out in the wash. But we know that difference is 12, okay? So that's the first thing that I know. Okay, then it says find the numbers so that x and y is the find the numbers x and y so that their product. Okay, how do I represent the product? Product is x, y. Okay, and in fact, I'm going to say that this is going to be a function. Okay, function is going to equal this. I'll figure out with whether it's a function with respect to y or x in a moment here. Okay, but this is going to be my second equation. And I'm just going to try and analyze this function, okay? But to do it, I don't like working with two variables, right? I want to eliminate one if I can. And so if I rearrange equation 1, move y to the other side, I get that x is equal to y plus 12, okay? And so what that means is I can take that and substitute this expression, y plus 12, in for x, okay? When I do, so x is now y plus 12 times y, okay? Now my function is in terms of y, okay? And that's fine. We can work with y instead of x. This is the same thing, okay? And if I simplify, this is like distribute the y, I'd have y squared plus 12y, okay? Now what do I know about this? This is, so in this case, a is in there, a is equal to 1, which is greater than 0, so it's concave up. Okay, this is what I want. I want to make sure that this thing is concave up so that when I find the vertex gives me a minimum. Okay? All right, so now I'm going to say from here, I'm going to say to find the min, find the vertex. Okay? So the y value that I'm interested in would be given by negative b. Okay, so again, this would be b. So negative 12 over 2 times a. A is 1. Okay, so then y is equal to negative 6. Okay, and then let's see, yep. And then if I wanted to find x, right, x was equal to y plus 12, so x is equal to negative 6 plus 12. Okay, so x is equal to positive 6. Okay, and so I'm just going to come over here and say the numbers are negative 6 and positive 6. Okay, and just to confirm, maybe some ways to check this. If we do 6, like the difference between them, so how far is it from 6 to negative 6? It is 12 units, so that satisfies the first one. And then their product as small as possible. This is where I might say to confirm confirm, spell it right, a minimum, I would make a graph, okay? And then the graph should show a minimum on the vertical axis right when that input variable is -6, okay? But there we go. We have one application. That was kind of fun, okay? Next application, and this one is a biggie. You will see this over and over and over again in this course as well as in physics if you go that far. But when we look at projectile motion, so that's when an object is fired from a cannon, gun, something or other, or in general when we have an object that is moving only under gravity, this general model applies, okay? So in this case, I had a potato gun when I was younger, and so you put a potato in the end of a big like cannon that's made out of PVC, spray a little hairspray in the back, and then you have an igniter to serve as like the catalyst to react with the hairspray and then cause an explosion, which then fires the potato out of the gun. Okay, so you have a potato being fired out of a potato gun. Okay, and so then we measure time in seconds, and then, or sorry, yeah, we measure time in seconds, but then really look at the height off of the ground. And so in this case, the height off of the ground would be given according to time. And this is the particular function that we're working with. Okay, so maybe just make note of that. All right. And then the general model information is given here. So A is acceleration acceleration due to gravity. V sub 0, V naught, is initial speed, and H0 or H naught is initial height. Okay, so this is saying we're under Earth's gravity 16, so it's initially traveling 16 feet per second, and then it's fired from a height of 4 feet. That's really what this model is saying. Okay, so when did it reach its maximum height? Maximum. Okay, whenever I'm dealing with maximum, I'm looking for the vertex. Or if I'm finding the minimum, I'm finding the vertex, since this is a quadratic function. Okay, in this case, A is -16, which is negative, right? So this means it's concave down. When it's concave down, that means I have a maximum. Okay, so this is lining up with the theory at least. Okay, so when, this is a time value. I want to know the time value. Okay, what was its maximum height? Okay, this is an h value. I want to know that. And then how long, okay, this again is a time value, was the potato in the air? Okay, so we have to find a time, a height, and another time. Okay, let's begin our analysis. When did it reach its maximum? Okay, so at least conceptually, okay, we know it was fired from a height of 4 feet, and then it went up and it came down. That's the overall idea, and I'm looking for this point. I'm looking for the vertex. Okay, so this time I'm looking for would be t value, which would be, again, this vertex. Since this is in model in terms of t and h, okay, we input t and we get out h, I'm effectively just finding the x coordinate, the first coordinate of the vertex here. So this would be -b over 2a, okay? B is is 16, so -16 over 2 times -16, okay? And so if I do the arithmetic here, the 16s would actually reduce, and the negatives would as well, and end up with 1/2. So half a second, okay? And I'll just say at 1/2 seconds, it is at a maximum or max height. And that would be my answer. Okay, now part B is asking what is that maximum height? Okay, we're looking for h value. That's the h coordinate of the vertex. So let's put in 1/2 and see what we get out. -16. And we're putting in 1/2 because we know that the height is maximum when time is 1/2 seconds. 1/2 squared minus 16, or sorry, plus 16 times 1/2, and then all plus 4. Okay, so let's do the arithmetic. I can do it mentally. 1/2 squared is 1/4, so this is -4, and then plus 8 would be +4, and +4 again would be a total height of 8 feet. Okay, it reached a height of 8 feet. Okay, so there we go. Now, the last question. How long was the potato in the air? Okay, now in this little sketch that I drew, okay, vertical axis is height, horizontal axis is time, okay? I know I can't have negative time, okay, so it would begin to be in the air at time is equal to 0, okay? When it would end would be this other place, time is equal to, I don't know what it is, okay? But how can I find that? Well, at that particular moment, okay, I know height is 0, okay? So if height is 0, how much is time? And I know height is given by negative 16t squared plus 16t plus 4 is equal to 0. Okay, let's try and solve this. So let's see, I could divide everything by 4. So I had negative 4t squared plus 4t plus 1 is equal to 0. Okay. So let's see this one. I don't know if I can factor it. I could try, and I don't think it'll factor easily, so let's just do the quadratic formula. Okay, so negative b4, so this is b, this is a, and this is c. So negative b plus or minus square root of b squared, so 16 minus 4 times negative 4 times 1, a times c, right? All over 2a, so negative 8. Okay, so t is equal to negative 4 plus or minus, let's see, this is going to be square root of 32, yep, all over minus 8, okay. Simplifying, I get negative 4 plus or minus, this is 16 times 2, so I could break that into 4 square root 2 all over 8, okay. And so then this is going to be negative 1 plus or minus square root 2 all over 2, okay. And this is as simplified as it can get. So I just divided everything by 4, okay? So I either have negative 1 plus square root of 2 all over 2, or, and I'm now realizing I forgot the negatives here. Oops, there we go. Or we'd have negative 1 minus root 2 all over 2, okay? And if you do the arithmetic, okay, this one, so these are both t values. Okay, if you do the arithmetic, this one is going to be negative and this one is going to be positive. Okay, so, and I forgot the negative again, darn it. Okay, so this would be the time that we're looking for. Okay, so how long was it in the air? If we would say it would be in the air from t is equal to 0 to, and then these are all negatives, I'm just going to make them all positive, to t is equal to positive 1 plus square root of 2 all over positive 2, okay? And if you do the arithmetic on this, this is about 1.207. So that means it was in the air about 1.2 seconds. Okay, and there we go. Okay, so we had to, in this last one, we worked with a model for motion under gravity and interpreted the information in terms of its vertex and then whether it was asking for time or height or whatnot. Okay, so this sort of model, this height and time model, is very common when we're looking at motion under gravity models. Okay, so be on the lookout for this and make sure to read carefully, maybe make a quick sketch to help you understand the scenario better.